Hi there, we're going to do a review problem with kinematics and forces. Now in this problem, Werner Heisenberg, inventor of the uncertainty principle, is coming to a stoplight when he slams on the brakes and skids for a distance of 57.6 meters before coming to a complete stop. This is his convertible car. I apologize for the drawing. And a cop sees this happening, and the cop says, you know, you were speeding in this 25 meter per second driving zone. And Werner Heisenberg says, no, officer, I knew how fast I was going, but I didn't know where I was. Get it? Uncertainty principle? Ha! You're so funny, Mr. C. Okay, anyways. Heisenberg argues that he wasn't speeding. And the skid marks were 57.6 meters long, and the coefficient of friction between the car and the road was 0.5. So we got to figure out if Heisenberg is actually telling the truth. Was he speeding or was he not? Well, the first thing I notice here is while the car is slowing down, there's an acceleration that's pointing backwards. That's why the car is slowing down. So I'm going to define my positive direction as pointing to the right and my negative direction as pointing to the left. Once the car has come to a complete stop, we know its velocity is going to be 0. So velocity final is 0 because that's when the car has already stopped. Alright, I'm trying to figure out whether V naught was 25 meters per second or faster or slower. But I notice in my problem I've got mass, I've got coefficient of friction. I'm willing to bet this involves forces, simply by the fact that we have coefficient of friction. Friction is a force. So I'm going to set up my F net equation. Now I know that the only force that is slowing this car down is friction, and it doesn't seem like there's any other force acting on it because it's skidding to a stop. So F friction is the only force here, and the mass of the car is 1200, and I don't know the acceleration yet, but if I can find the acceleration, then I can figure out using kinematics how fast the car was going initially. So let's try to figure out the acceleration here. F friction, that's mu times F normal. And in this case, the normal force, the thing pushing the car into the road, is its weight, mg. So when I plug in 0.5 times the mass of the car times acceleration due to gravity, which is 10, I'm able to find that the acceleration is 5 meters per second squared. Okay, a simple way to do this, by the way, is to just cross out the mass, and then over here you've got 0.5 times 10, which is 5. But in any event, we now know that our acceleration is 5 meters per second squared. Okay, so acceleration's 5, the final is 0 meters per second. Change in displacement. Change in displacement is 57.6 meters, and I want to find V naught. What equation uses all of these variables? Pause right now and see if you can figure it out. Okay, so you figured out what the equation is. Vicky is a very good bet because it's got acceleration, change in displacement, final, and initial velocity. So I'm going to plug in what I've got here. I want to find V naught. I've got V final, which is 0. Acceleration is, oh, I should have said that this is negative 5, because remember it's pointing in the negative direction to slow us down. It turns out that's not going to make much of a difference in the end, numerically. So this is negative 5, and then 57.6. For all of you mathematicians out there saying, oh, but it's going to become a square root of a negative number. Yeah, but you just, you know the magnitude. So V naught squared is equal to, this number stuff over here is negative 10 times 57.6. That's 576. And then when you add it over to the other side, it becomes a negative. So when you take the square root of both of these things, you get 24 meters per second. And will you look at that? Heisenberg was certain about his velocity. He was not speeding.